We are going to start off with put on your 3D glasses. We're going to enjoy this. So this is purely because I came across these while our staff helped me find them too. Just some gorgeous 3D images of the surface of Mars. So yeah, some big holes. Here's a crater.
Wow.
With some recurring slope lineae. There's little dark stripes on the edge of the crater. I'm going to talk about those. So that's like a little sand dune edge. See the edge of a cliff there. And then lastly, this neat looking crater. Okay, so beautiful surface of Mars. Now, we have been talking about one of the most recent landers on Mars, the InSight lander. That instrument on the left-hand side is the seismometer, and on the right-hand side is the one they're calling the mole, which is supposed to measure the heat flow of Mars. Well, the seismometer, properly deployed, as far as I know, everything is good with it. And the mole, well, they did deploy it. Here's the little video of it getting out to the surface, and they placed it down there. Everything was good. They had a cake. Congratulations on the successful instrument deployment. Here it is. And we're going to show you how it drills down in there. It actually pounds itself down in with a very clever mechanism. It sort of spirals up and then falls down. Spirals up and, well, it's not really falling. There's a spring up above that shoots it down. So very cool mechanism. It's supposed to drive itself down into the soil of Mars. If it hits any rocks, it's sort of supposed to shear off of them and steer around them and go down, well, fairly deep into Mars. And here it is, and something strange happened as it was pounding in. Notice it's offset itself. That's not good. It lifted up the housing and it moved it over, which said it did run into something. And we can even see it move there. Here it is moving. So it ran into something. Now, we were promised that the surface wouldn't have a lot of rocks, and it doesn't. There's not a whole lot of rocks there. It was a good landing spot, so it seems like they got kind of unlucky with it. And as of right now, the mole is only down about 14 inches. Now, it's supposed to go down, if I'm remembering right, 5 meters. So they're trying to figure out what to do about the mole, still troubleshooting it. I have not heard if they have any fixes for it yet, but the mole's not very deep in, and they have some work to do with the InSight lander. They can't pull it back out. It drives itself down in, but it made it so not deep. It's so shallow in, maybe. If it had made it much further, maybe not. But I know they're looking into all that. The cable, I'm sure, isn't very thick that it's connected to. You don't just want to grab it and yank it out. So we'll tell you more when we hear more about it, for sure. Now, this is, of course, a shot from Opportunity heading off in the distance, but it makes you wonder, God, we're driving around on Mars all this distance. What if we could only fly? Well, NASA engineers have been working on a Mars copter, believe it or not. So
Get to the chopper!
that's right. Get to the chopper. The next time our Mars copter flies, it will be on the red planet. I was stunned to see them say that. They've had 75 minutes of flying time in engineering mode. Well, 75 minutes, it must be good to go. Well, this is a test version. It's a test project. It's being sent with the Mars 2020 lander, and it will fly around on Mars. It's able to fly in that atmosphere that's only 1% as thick as Earth's because of those rotors. They turn super, super fast, and it's going to fly around on the surface. It's being sent with that lander, or the 2020 rover, rather, that's going to go there. Mars has lots of features that look like liquid water flowed on the surface in the past. So some researchers decided to go look at those rivers and really study them in detail. And you see some that sort of appear little snakes through the terrain. Here's another one that comes along. And then these bottom ones are actually lifted up above the surface. Those are the oldest and most weathered rivers. The river lays down sediment, and that sediment doesn't erode as fast as the stuff on the banks. So after many billions of years, the bottom of the river is left a little higher up. What's interesting about this result is they found that some of these rivers flowed perhaps as recently as only 1 billion years ago on Mars. We were thinking these were 4 billion years ago, 3 to 4 billion years ago, they might have been rivers. So the fact they're seeing hints that some of these channels were put in place only 1 billion to 2 billion years ago is sort of a different story about water on Mars. Now, they didn't flow slowly. They flowed very quickly, and they didn't last a long time. And they don't see any signs that there were plants along the banks of the rivers either that would have held the banks in place. So certainly different than what we see here on Earth, but they look like the rivers we see on Earth before plants came into place on Earth. So it all kind of does fit together, but they're testing these rivers. Mars Express made some interesting measurements of some of the basins on Mars. They looked at all these different basins, and they discovered that it looks like they were filled with water in the past. Now, maybe not so surprising, you think a basin's going to fill with water, but dry craters, one that doesn't go very deep, the crater, if it's between 4,000 and 5,000 meters deep, had water in the bottom. And that was for all these locations. All of those craters see signs of water in it. You see things like a channel that's cut in the side. The stepped delta is where it kind of comes down. You see the water that was there for a while. Sagging valleys. Also, you can see, skipping forward here, fissures in the bottom of it. And this looks like it fell off the side of the hill there, the slope. It was a landslide that kind of fell in. And when you have water there, it kind of loosens things up and it can fall in. All these are signs that are consistent with these being filled with water that kind of came and went over time and slowly got lower and lower and lower and then dissipated, went away completely. Now, why does that matter? Why do we care? Well, all of these are at the same level, yet they're at very different locations on Mars. This tells us there was groundwater. There was a layer of water deep on Mars between 4,000 and 5,000 meters deep. That's the same as the light blue you're seeing there, where we think there was an ancient ocean on Mars. Mars has signs of shorelines that look like there might have been an ocean 4 billion years ago, and then another one 3 billion years ago. That's when these basins were filled with water. And they're at the same depth. So Mars maybe had connections. The water was all connected underground. So a story of water being much more global on Mars than we thought. Now, these little stripes you're seeing here that look like water has been flowing down this slope, those are called recurring slope lineae. Why are they called recurring? They're called recurring because they come and go. You can see them appearing in the springtime. They get longer and longer and longer throughout the summer, and then they disappear, and then they come back the next season. Now, they're located all across Mars. Valles Marineris has a bunch of them. There are southern ones. There are ones in the northern region. But they're all kind of confusing. We didn't know what they were. Some folks thought maybe it was dust cascading down the hill because they were all on very steep slopes. Others thought that maybe it was deliquescence. There was moisture in the air that was being deposited on the surface with just enough to darken the surface. Maybe it isn't even a real flow, it's just a darkening. Well, these researchers said, I don't think so. We think that this is similar to springs on Earth, that where you have cracks, fissures along the craters, and then also radial cracks when the crater hits, right there's where you're seeing the slope lineae. So you have a crack there, and then you have a crack there, and the slope lineae are lower. Again, dog leg effects, multiple displacements. The land's been moved against one another. There's a fault there. So there's a crack that goes very deep that can allow these recurring slope lineae to show up. And again, another location where you see concentric rings. These are, again, fractures that go deep in, and then radial fractures. And where they cross, you get the little green crosses, and that's where we're seeing the slope lineae appear from. So now if we plot how many, we're seeing the frequency, how many of the concentric faults we see, and how many of these recurring slope lineae we see, they kind of match. Where you see more faults, you see more recurring slope lineae. So now this is not absolute proof that they're connected, but it certainly hints that it's worth looking at. Because if where there are faults, you're seeing these recurring slope lineae, and where you don't see them, there aren't any faults, that's some strong evidence we want to go poke at. And their idea is we don't see them in the winter because it freezes. The permafrost is frozen up at the top. The summertime it thaws and allows these springs to start working their way up. And then they trickle throughout the entire summer, get longer and longer and longer. It refreezes, shuts it off, and it ends. So the story makes sense to me. This is the sort of water we see in the deserts here on Earth. We see this sort of action happening in Antarctica. And the picture is pretty good. Whether this is the only mechanism, I don't know. There'll probably be another paper in a few months that contradicts this, but this is how science is done. We take it forward step by step. The Curiosity Rover is still operating on Mars. It's still exploring Gale Crater and doing amazing things, but it actually made some observations of the two moons of Mars, Phobos and Deimos. And there goes little Deimos passing in front of the sun. So very cool. It's actually seeing a transit, as this would be called. So fun watching it slow poke across. And then it saw this. Yeah, whoa. And that's Phobos crossing the face of the sun. This would actually be an annular eclipse. Phobos is big enough in the sky that this would qualify as an annular eclipse, evidently, by the folks that make those decisions, whatever governing body makes it. Now, what's cool about this one is it actually looked at the light in the crater where it is, and you can see the darkening, the shadow. as that happened. So it actually blocked out enough light. It got a little bit darker for Curiosity. Very neat. Curiosity also saw this muddy rock that has cracks in it. That's consistent with mud that was laid down that dried out. And there's another little rock that looks dried out. It saw these pebbles that look a lot like pebbles in the bottom of a stream, and some of them are extra round and a little bit bluer, and they're probably very similar to something that Opportunity saw. Those things we call blueberries or hematite that are actually laid down in standing waters. They can be preferentially made there. So Curiosity seems to have seen a sign of liquid water there in Gale Crater as well. Now Mars, of course, just like Earth, did get impacted by asteroids and meteors. They smack into meteorites, making meteors in the sky. So they simulated it in a lab, and they learned they could actually make some of the chemicals that life needs. They could fix nitrogen to some of the rocks, and that makes it usable by life. And nitrogen is one of those chemicals that life needs. It's one of the Schnapps chemicals. So another sign that Mars in the past might have been had the conditions that might have been habitable. Curiosity made a measurement of methane in Gale Crater, which was very interesting. Methane doesn't stick around. You need to be pumping it into the atmosphere because it breaks down rather quickly. It interacts with other elements and is gone. So if we're seeing it, it has to have a source. Well, one of the sources for methane is biology. Now, does that mean we've seen biology? No, there are other ways to make methane. It could have been locked in underneath the surface. But what's new today is that the Europeans and Mars Express confirmed the measurement that Curiosity made. So Curiosity made the measurement from Gale Crater. Mars Express made the measurement from orbit and saw it in Gale Crater. Now, we thought it might have been coming from Gale Crater, might have been being released, and it was a local effect. Well, for Mars Express to be able to see it, it couldn't have been small and local. It must have been released somewhere else and had been transported into Gale Crater. Had to have been a larger effect. So the two happened at the same time. It's real, but it couldn't have been something small that happened right in front of Curiosity. It would have been too small for Mars Express to see. So that's our Mars roundup for this month.
A lot of Mars.
A lot of Mars. A lot of Mars stories.